Welcome class, myself Professor D.S. Rai, Professor Department of Civil Engineering, BBD IITM Lucknow. The course today we will take up KCE 076 Urban Transportation Planning. We have already covered 38 lectures. Today lecture is 39, in which we will cover transportation system management. References we have taken Chakravarti Partha and Das Animes, Principle of Transportation Engineering, Papa Costa and Prevendendas, Transportation Engineering and Planning, Kadiali and Lal, Principle and Practices of Highway Engineering, R. Srinivasa Kumar, Introduction to Traffic Engineering, S.K. Khanna and Justo, Highway Engineering, and some material have been taken from NAPTEL and Internet. Content today we will cover transportation system management, aim of transportation system management, transportation system management measures, regulatory techniques, a reason for being one way, reversible street, reversible lane, transportation system management policies, transportation system management strategy, free way service, patrol, public transit, ride sharing, pedestrian and bikeway facilities, park and ride lots, mobility rest areas. We will take up one by one. First of all, transportation system management. What is transportation system management? Transportation system management is a set of techniques used to increase the capacity of a piece of transportation infrastructure without increasing its physical size. Most often, these techniques are used in context of roadways. In this context, transportation system management technique may include change to traffic signal, such as coordinating them or introducing ramp metering, or minor changes to road geometry, such as strengthening corner or lengthening merge lane. These two cost intervention can be very effective in reducing congestion under some circumstances. Due to low cost of transportation system management, it is often included as a reference option in cost benefit analysis and environmental impact statement for new roadway or mass transit link, such as busway, metros, light rail lines. It is typically considered in conjunction with the default no built option. Transportation system management is a planning, monitoring and controlling or influencing of traffic modes. Now, aim of transportation system management: maximize the effectiveness of the use of existing infrastructure, ensure reliable and safe operation of transport, address environmental goal, ensure fair allocation of infrastructure space, road space, rail space or slot, etc., among competing users. The transportation system management we will say TSM maximize the capacity of the street system and reduce the demand on it. Although some of them may be expensive to implement. TSM measures are typically low cost localized improvement that attempt to take full advantage of existing street infrastructure, thereby increasing the efficiency of the street system. Now, transportation system management measures. The spectrum of TSM measures is wide. The measures that are applicable will generally fall into one of the 6 categories listed below, that are regulatory technique, traffic control devices, traffic segregation technique, demand management technique, bus priority technique, self enforcing technique. Regulatory technique. The regulatory technique are further divided into 5 management technique. And what are they are? First is one way street, reversible lanes, turning moment restriction, closing street. So, these are the 5 management techniques. First one is one way street. This is the technique where the vehicle movements are possible only in one direction. It optimizes the road capacity and minimizes the conflict. It is the best suited if the network is in grid pattern. Reason for being one way. The street is too narrow for the movement in both directions and the road user unable to cooperate. Second, to prevent driver from cutting through residential street to bypass traffic light or other requirement to stop. Part of a one-way pair of 2 parallel one-way street in opposite direction, a divided highway. For a proper functioning of a system of paid parking or other paid access to increase traffic flow and potentially reduce the traffic congestion. Now, reversible street. It is a technique adopted on the way where one direction traffic is about twice the other's direction. To adopt this technique, another parallel street should be available to accommodate those traffic. Reversible lanes. It is a lane in which traffic may be travel in either direction depending on a certain conditions. Additional lanes should be provided to the peak flow direction by squeezing the carriageway width of opposite traffic flow. Typically, it is meant to improve traffic flow during rush hour by having overhead traffic light and lighted street sign notify drivers which lane are open or closed by driving or turning. The presence of lane controls allow authority to close or reverse lane when unusual circumstances such as construction or the traffic mishap require use of fewer or more lane to maintain orderly flow of traffic. The technique is normally implemented if the road lane is more than 4 lanes. The traffic cones are generally used to delineate boundary of additional area taken away from opposite carriageway. Reversible lane during morning and evening peak hours. Turning moment restriction. It is a technique used when the turning moment of the vehicle is restricted or banned to minimize the conflict point. It also helps to minimize the traffic signal phases at crowded intersection. Closing a street. It is a technique adopted to improve the flow on the main street by minimizing conflict. The side street may be used for the parking purposes or the pedestrian purposes according to the requirement. Implementation transportation system management. Transportation system management strategy improve the flow of traffic without adding additional roadway lane miles. They frequently provide a relatively low cost way to increase roadway system performance. However, not all TSM strategies are inexpensive. TSM measures are useful when a roadway is approaching congestion, but general street or highway capacity increases may not be feasible or in keeping with the community vision. Financial constraint prevents implementation of a general street or highway capacity increases. The traffic congestion exists only at the specific bottleneck that can be addressed with TSM improvement. The policy for transportation system management were developed based on a review of existing policies in order other state, regional or local plans. A such as a Oregon transportation plan, B Deschutes country transportation plan system, Deschutes country ITS plan and City of Bend transportation system plan. These are the plans because these are in a states a different type of transportation plans. These policies will help guide the future development and management of the transportation system, support the access management policies of the Oregon Department of Transportation along the state highway, work with the member jurisdiction and the agency to adopt legislation that protects the integrity of the regional roadway by managing public and private accesses. Work with the member jurisdictions and agency to develop a parking regulation that support land use and travel demand and that also encourage the use of alternate modes. Work with the member jurisdiction and agency to implement the comprehensive intelligent transportation system program per the Deschutes country ITS plan. Support effort of the member jurisdiction and the agency to update traffic signal and traffic signal control system hardware and software and implement signaling timing strategy to optimize the system efficiency for all modes. Support effort of the member jurisdiction and the agencies to remove traffic signal where an engineering study demonstrate they are no longer warranted based on land use charges that have resulted in decrease at travel demand. Support effort of the member jurisdiction and agency to install new traffic signal where an engineering study shows they are warranted to support the land use changes that have resulted in the increase the travel demand. Work with member jurisdiction and agency to investigate the feasibility of utilizing automated speed and red light enforcement at high accident location to improve safety and reduce the manpower needed by law enforcement and adopt legislation as needed. Support effort of member jurisdiction and agency to utilize traffic calming technique to reduce travel speed and cut through traffic on roadways where the traffic conditions do not match the roadway intended design. Encourage member jurisdiction and agencies to consider geometric improvement to enhance efficiency and to provide safety for motorists, pedestrian and bicycles. Now, encourage member jurisdiction and agency to consider using value engineering or a system engineering to deliver transportation project more efficiently and cost effectively. Promote new technology and a strategy to effectively manage transportation asset including roadway, pavement, bridges, right of way, public transportation facility, traffic signal, ITS field devices and other infrastructure to maximize functionally and prolong the lifetime of the transportation system. Now, transportation system management strategy. First is traffic flow improvement. The roadway re-stripping, a spot widening, channelization, a ramp metering, auxiliary lanes, elimination of on-street parking and computerized signalization are techniques currently used to improve the flow of traffic without new road construction. Roadway re-stripping seeks to increase the numbers of lanes by reducing lane width, thus increasing the traffic capacity. Channelization, which is often done in conjunction with the re-stripping, add turn lanes to busy roadway to eliminate traffic backup behind cars trying to make turns. Auxiliary lanes are often added to ease merging of traffic onto and off freeway such as I-80 elimination. I-80 is a system in USA. Elimination on street parking is done to add lanes and thus capacity to heavily travelled roadways. In addition, traffic backup caused by the vehicles entering or exiting on street parking spaces is eliminated. Computerized signalization seeks to coordinate signal timing to a smooth traffic flow. Freeway service pattern role. Approximately half of the delay experienced by the travelers in United States is due to cause other than simple high volume of traffic. Much of this non-recurring congestion occurs as a result of traffic accident and stalled vehicles. FSP, quickly identifying and removing vehicle accident reduce travel delay by returning traffic capacity to normal level. FSP programs are designed to reduce the traffic congestion during peak commute period on area freeway by removing traffic impediment such as the mechanical problems or that have been involved in accident, as well as assisting the motoring public. Now, come to the public transit. Public transit service is most widely used TSM measures in the pleasure country service resident who depends on transit for commuting to work and school and for shopping, medicals and leisure trips. For more comprehensive overviews of the public transit and the passenger rail services operating in pleasure country, see the public transit and passenger rail section of the action elements. Both Rogeville and pleasure country provided commuter bus services to downtown Sacramento. In addition, pleasure country subsidizes 10 commuter van pools that provide an alternative to driving alone. The Capital Corridor Joint Power Authority CCJPA provides intercity passenger rail services between Autobahn and San Jose with a stop in the Rocklin and Roseville in the pleasure country. Now, come to the ride sharing, and it is very important and it is adopted worldwide. There are several coordinated ride sharing program that serves a pleasure country. The Sacramento Area Council of Government manages the regional ride share program covering the pleasure E1, Diado, Sacramento, Yellow, Yuba and Sutter countries. It is the part of a statewide network of ride share agency. The purpose of the regional ride share program is to encourage the use of carpooling and other alternative transportation mode for traveling to work, school, personal trips and recreation. The regional ride share program includes a toll free, easy to remember like 511 to call for the information and the database of commuter interested in ride sharing, carpools or van pools and extensive outreach program to the employers. Pedestrian and bike way facilities. By making these methods safer and more convenient, pedestrian and a bike way facility makes the bicycling and walking more attractive than alternative to the automobile. To further support biking as a available alternative to driving alone. Pacer country bike maps are available to the public. For a discussion of a plan for pedestrian and bike way, the facility with the Pacer country, see the non-motorized transportation section of the action element. Park and ride lots. The purpose of the park and ride lots is provide a central meeting place adjacent to the major travel route where the commuter can congregate and form carpool or catch buses for the remainder of the commute trip. Non-commuter can use these facility for recreational purposes such as rail across for bicycling, biking and AKtrain users. Caltrain operates numerous park and ride a lot in a Pacer country located along the I-80. Mobility rest area. Mobility rest area are to provide to increase driver safety and satisfaction. They offer motorist and commercial driver regular stopping opportunity to rest, receive pertinent travelers information and access to restroom facilities. There are currently two rest area in Placer country located I-80 at a Golden Run and Donor Summit, and one additional facility at SR20 just west of I-80 in Nevada country. One new rest area has been identified by the Caltrain for I-80 east of Turkey, although no funding has been identified for its implementation. So, this is the all about the traffic system management. Thank you very much. Thank you.